share the PPT. Hello everyone, so today we are presenting our computer vision's final project, and the name of our project is measuring effect of training set compression on task performance. And we have three members in this project: Neil Tumor, Priyank Danani and Vinayak Prajapati. And in this project we will explore how reducing the amount of training data affects the performance of a CNN classification. So we'll go through introduction first. So this project focuses on understanding how training set compression influences the accuracy of CNN classifier used for e-commerce product images. So we use the fashion dataset, fashion amnist dataset to simulate the real product categories. So imagine an e-commerce company creating a mobile app that classifies product images uploaded by the user. So since mobile devices have limited storage and computing resources, they cannot handle the large training datasets. So the goal of this project is to determine how much we can reduce the training data while still maintaining the high accuracy. So this helps us find the ideal balance between the model performance, efficiency, and the real world deployment constraints. So in the next page, we're gonna see the GitHub repository structure that we have for our project. So the photo shows the structure of our GitHub repository. So we keep our main experiment notebook Python script, weekly progress logs, and the result outputs well organized. So the result folder contains all the results and the outputs of our project. Requirements list that requirements.txt contains all the libraries needed for our project, and in the readme file which explains the entire project workflow, the structure, and everything that ensures our project is clean, reproducible, and easy to follow. And the next page, we're gonna see the libraries we use in this project. So these are the main libraries that is used in this project. So the first one is the TensorFlow and the Keras, which is used to build and train the CNN models. NumPy and Pandas help with the data processing and manipulation. So Matplotlib and Seaborn were used to visualize accuracy and loss curves. And we also used Sklearn for the evaluation metrics and analytics. So all these tools together made it possible to implement and analyze our model efficiency. Next page. Okay, so our dataset is fashion amnist benchmark dataset widely used in the computer vision. It contains 60,000 training and 10,000 test images, each 28 pixels and grayscale. So there are 10 products categories such as shirt, trousers, sneakers, and bags. To simulate the dataset compression, we use only 10% of the training data, which is about 6,000 images, while keeping the test set unchanged. So this allows us to measure how much performance drops due to compression. And the next slide will be explained by the Vinayak, our second member of the team. Hello.
Today I will explain about the model used in this project, like CNN architecture and everything. Uh, First, I'm starting with uh, our model is convolutional natural network built with the TensorFlow kernels. It's include the convolutional layer for the features extension and the ReLU activation function and then max pooling layer and the flattening and then dense layers, the final softmax layer output and prediction for the 10 categories. So we use the same model architecture for the both the full dataset and the comprehensive dataset to ensure the consistency. And then both model were the trained for the 15 epoch with a bench size of the 128 using for the Adam. But like this, 128 page is the like very grateful to the train the database, and also the like 15 epoch is not like very much high, but our system is like not that grateful to accept 50 or 55 epochs. So we ensure like the 50 epochs. And well, firstly I explained the about the codes and like GitHub repository. So this is our GitHub repository, and our code is stored in the computer vision final project .ipnb. And first one is the result, and the readme.md file explain about the description and then abstract of our project, and these are all the weekly reports. So uh, you can say easily what we do in every week. So now I am explain about our project. So my first cell is like import all requirement libraries. So I import like TensorFlow cons and then NumPy, Metobloty, Pandas, Cebrons, and then Skeleton Learn Helpers library. So this library is useful our project. So that's why we install this library, import this library, and the result is so like our library is successfully imported. So my second cell is like configuration and setup. So the my second cell is easily so that our class name and then flex the random seeds, and for the report durable and experiments, and then define the class name and then key hypermeters. So compression ratio is 10% and epoch and bit size. So and the output is the showing the short project description and the chosen configuration. And then third cell is so the load and explore the dataset, and I use the load fashion minist. It's easily load the data from the X train, Y train, X test, and Y test, and the output is showing like our data is successfully imported. And then it's easily show like print the shape and number of the class, and then show the sample image, and also plot labels distribution for the train and test to understand the class balance before any compression. And just second. And then my third cell is showing easily like data processing. The this cell is explain about like normalization pixel value to 0 to 1, and then repairs to the n 28 1. Then This cell is showing about the like a normalization pixel value to 0 to 1 and then reshape to the end 28 28 one dimension with the channel of dimension and then convert into the label to one hot encode vector like two categorical and this cell is print the shape of the process array and then return the process to train and test set and then my cell. So you can easily see the output of this cell, um, like sample product image from the database. So they can easily compare and then show the result about our data and training and testing data. So in this cell, we just uh, do the data processing. So prepare the data for the training. So like the name is like a random subsampling and then randomly pick of the 10% of the training image. So so we can use the left data from the test data and then console grady used for this function is used for like vector and then pairwise distance to imperative select point that are far from already chosen ones. So maximally device and subset. So and these three method are report how many sample each subset contains. And then the cell number seven cell is like a visualization compressor label distribution. So convert the compressor label back to the intake from the argmax, then plot bar chat of label code for org- original, random, stratified, and then cache central dataset. So let's visualize the compare how each method preserve or destroy distorts that classes distribution. So this all the codes and this one all the output for the like layer output and perm. So these are the result for our epochs and this is the output like model baseline model training performance. So you can easily say see the performance of our data set and the and this all the same things like the epoch and run the data and test and training data and the last visualization comparison data. It so the compare the derivable materials like effective score and the correlation between the comparison and the performance. So this one is the result for like correlation and compromise and then distribution after the compression. So this one and this one is also so all code are same and this all are the result and this one is the final result. The first diagram is so the accuracy visual compression trade-off, and then second one is the methodology effect compression, and then the practical development guides. These are the main uh, resource for the construction contribution, and then compare the training data set used, and then this is our completion. And now I move from my slide. So this all the methodology we are using in the this project like dot oh, methodology that's already talk in my previously about this methodology and this is the output. I already explained the output in the code base and now this is the analysis is explained by colleagues.
Hello, so my name is Priyank Dhanani. So now I'll be explaining you about this final analysis. overview. So we seen that this our project examines how reducing the training dataset affects the accuracy of the CNN classifier used for the e-commerce product image recognition. The goal is to simulate to mobile app development in the where storage and the computational power are limited. Our baseline model trained on the full 60,000 samples achieved an accuracy of 0.9035. When compressing the dataset to only 10% of its size, we see a noticeable accuracy drop across methods. Among the compression techniques, stratified sampling performance the best, maintaining at the accuracy of the 0.8436. For extremely resource constrained environments, K-central study greedy is the recommended because it reduces the dataset size significantly while keeping accuracy at the acceptable level. The main takeaway is that while compressing improves efficiency and the reducing training cost, it also limits the model's exposure to feature variability, resulting in a reduced generalization performance. Choosing the right method depends on the balance you want between efficiency and accuracy. Now, next slide, please. So finally we go on the conclusion. So the result clearly shows that the training set compression has a directly effect on the CNN performance. As we reduce the dataset size, the model loses exposure to critical feature variable, which limits its ability to generalize. However, moderate compression around 10% still maintain more than 89% of the original accuracy. When using a smart select method like stratified sampling or case center greedy, this makes a compression more difficult or highly valuable for the mobile and the edge deployment where the memory and processing power are limited. The key conclusion is that compression is useful, but it must be applied carefully. Over the compression reduces accuracy significantly, and the different tasks may redirect differently. Ultimately, the finding the right balance between the data size and the computational saving and the model accuracy is essential for the real world application. Thank you so much.